Welcome to the next video in the Oregon FFA Career Development Series for the Forestry Career Development event. In this video, we'll cover map reading, a skill that may seem basic in the age of Google Maps and GPS, but remains essential in forestry. Topographic quadrangle maps provide critical information from determining land ownership to understanding terrain and are key to planning everything from forest harvesting to firefighting. Let's get started.
I'm Jerry Risk. I'm a forester with Roseburg Forest Products. So legal land descriptions with township, range, and section is a day-to-day occurrence for us as foresters and land managers. That's how we identify where all of our ownership is. It's how we recognize where harvest units are, where fires may be. It's all called out on a coordinate system and also township, range, and section. And once you do it long enough, you start hearing township ranges and you just pretty much know exactly where it is and know whether that's in your ownership or not and the land you manage. What's important to remember is we're in a checkerboard ownership in Oregon, in Western Oregon. And so we have a lot of adjoining neighbors and straight lines. And so understanding township, range, and section is very, very important when we're laying out harvest units or harvest boundaries or even roads, and knowing where property lines are, knowing where section corners and quarter corners and 16th corners are, to know where those property boundaries are when we're doing those activities. So in high school, I was very involved with the National FFA organization and Oregon FFA at Sutherland High School. Really became interested in forestry by participating in the Envirothon, or the Environmental and Natural Resources CDE. That really grew the passion and interested in me to manage our natural resources, which led me to Oregon State University, where I eventually landed in the College of Forestry and graduated with a degree in natural resources. During my career at Roseburg, I've held a few different roles. I started as a forester in 2018. And after a few years of doing that, I had the opportunity to work as a contract logging administrator, where I oversaw anywhere from a dozen to 16 different harvest operations on our tree farm. I spent a little bit of time in our Springfield corporate office as Roseburg sustainability manager, and now I'm back working as a forester out of our Western regional office in Dillard.
When settlers headed west to the Oregon Territory in the 1800s, the U.S. government needed a way to describe and divide that newly settled land. So they set a starting point, the Willamette Meridian, marked on a hillside west of Portland. From that spot, every legal land description in the territory was measured, creating a system to organize the newly explored and settled land. The Willamette Meridian was carefully placed to stretch all the way to the California border, while avoiding Lake Vancouver. The baseline was set to run through the natural gap between Cascade Locks on the Columbia River and Mount Hood. From that starting point, everything else was mapped. Land was divided into townships, named according to the coordinate system based on the meridian and baseline. Township refers to how far north or south a piece of land is, while range measures how far east or west it sits. For example, a township might be named Township 22 South, Range 3 West. This means it's the 22nd township south of the baseline and the 3rd township west of the meridian. You can think of it much like an XY coordinate system on a map. So what is a township? A township is a square piece of land, typically 6 miles by 6 miles. It's divided into sections, each one measuring 1 square mile. The sections are numbered starting in the top right corner, moving left across the row, then dropping down a row and snaking back to the right, continuing this serpentine pattern. While this might seem a strange and unfamiliar numbering system, it's actually one we've seen before. In math class, you might have worked with an XY coordinate plane where quadrant 1 is in the top right, quadrant 2 is in the top left, quadrant 3 is in the bottom left, and quadrant 4 is bottom right. In other words, it's a system that starts in the top right, moves left, drops down, and continues back to the right, just like the section numbering we saw here. Let's focus on these sections. As mentioned, each township has 36 sections, each 1 square mile, or 640 acres. Sections are often divided into halves or quarters to make legal land descriptions more precise. Once we know a section's description, we can even calculate exactly how many acres it includes. Here we see the north half of this section, so how many acres would it be? The answer is 320, or half of 640 for the whole section. We could also divide sections into quarters. In this example, the southwest quarter would be 160 acres, 1/4 of the full section. A land piece might be half of that again, say the east half of the northeast quarter. And now we'd have 80 acres, half of that quarter. In this Google Maps view of Oregon, you can see how these sections create a checkerboard pattern of ownership, especially in our timbered areas. Each square mile has been managed differently depending on who owns it, some private, some public. If you look closer, we can see variations in harvest patterns within sections. The boundaries remain clear, showing exactly where each section begins and ends. So how does someone actually use the township range and section system to find their property lines and boundaries? For decades, surveyors have placed corner markers where sections meet. All property boundaries are measured from these corner and quarter corner markers, which separate the different sections. We can find many of these markers out on the land today, often set in stone, metal, or marked by bearing trees that were used as reference points. A closer look at one of these brass caps, as they're often called, shows exactly which sections, township, and range come together at that point. These markers can then be cross-referenced with a map to pinpoint exact locations. As we look at this brass cap, it's a little trickier to read, but here we can see the boundary where two townships actually meet, with 4 sections converging at this point. On the top side is Township 25 South, Range 5 West, between sections 32 and 33. On the other side is Township 26 South, where sections 5 and 4 come together at the same point. Let's look at some example questions and where to find the answers on an example map. First question, what is the name of the topographic quadrangle map we're using? We can see here in the top right corner, this map is called the Kellogg Quadrangle. That's where you'll usually find the name on a USGS map. Second question, what townships are shown on this map? Remember, a township is a 6 mile by 6 mile section of land that is identified by its township and range coordinates. On this map, we can see in the top left, Township 22 South, Range 8 West. Next to that, to the right, is Township 22 South, Range 7 West. Below that, in the lower left, we'll see Township 23 South, Range 8 West. And then in the bottom right, the Township 23 South, Range 7 West. Again, these are just pieces of each township, not the full township, but you can clearly see where they appear on the map. Another common question is, what is the scale of this map? And what is the contour interval? We can find both near the bottom of the map, usually in the legend. Here, the scale is shown as 1 to 24,000, meaning 1 inch on the map equals 24,000 inches in real life. You'll also see additional scales for meters, kilometers, miles, and feet. Just below that, we find the contour interval, which in this case is 40 feet, indicating that each contour line represents a 40-foot change in elevation. Looking at this example map, we can see the bottom portion is flatter, the contour lines are farther apart, and it takes longer to make a change of 40 feet in elevation. As we move towards the top of this picture, the lines get closer together, showing steeper terrain. We can also read the elevations on the darker contour lines. For example, we see 400 on one dark line and 600 on the next. These darker or index lines mark every 200 feet of elevation change. The lighter lines in between each represent that 40-foot contour interval earlier referenced. Another question you might see is, what is the name of the quadrangle map southeast of this one? In other words, if you were to move off this map to the southeast, which map do you need next? Different maps display this in a slightly different way, but it's usually shown in the legend at the bottom as a small grid. In the grid, the center square represents the current map, and the surrounding numbers indicate the maps in each direction. In this case, moving southeast would take you to map number 8, Tyee Mountain. That's the map you need if you continue in that direction. Let's try finding a specific point. If we're asked, what is the elevation of the peak in the northeast quarter of Section 33, Township 22 South, Range 7 West? We would first locate Section 33 on the map, then narrow in on the northeast quarter of the northeast quarter. On the map, peaks are often marked with an X and an elevation number below it. Here we can see the elevation is 1,417 feet, which makes sense. The contour lines show we've already reached at least 1,400 feet at the last dark line. Let's make it a little more interesting. This question asks, what general direction does Williams Creek flow in Section 3 of Township 23 South, Range 7 West? If we look at the map, we can spot some elevation markers and remember that water always flows downhill. Tracing the elevations upstream, we see the higher points are to the east. That means, in Section 3, Williams Creek flows generally from east to west. And finally, as a little throwback to the compass and pacing session of this series, what is the declination on this particular map? Remember, each map has its own declination value. On this map, we can find it in the legend at the bottom, showing a declination of 18 degrees east. Different maps will show different values, and we can learn more about how to use declination in the compass and pacing video in this series. In the Forestry CDE, the map reading practicum is combined with the compass and pacing practicum. You'll have 40 minutes to complete both. The map reading portion is based on a topographic quadrangle map, typically with 10 multiple choice questions worth a total of 50 points. If you'd like to practice, you can download your own topographic maps, even from your own area, from the United States Geological Survey (USGS) website. Simply Google USGS Topo Maps and follow the link. On the homepage, select Access USGS Topo Maps, then scroll down to find the Historical Topo Map Collection. From there, you can zoom in on your area, click, and a list of available maps will appear on the right. You can also search and filter the selection, and even use the timeline slider at the top to choose maps from different years. One important note: not all map versions display township range and section, since other survey systems are sometimes used. For learning and practice, it's best to choose a map that does include township and range. Use this resource and others as you prepare yourself for the Forestry Career Development event.